Okay, hello. I'm going to talk you through this revision material. I'm going to give you a brief overview. Now, this is not to literally spoon feed you the information. This is more to give you some thinking points and then direct you as to where you might want to go and look for a little bit more in-depth information. So see this as a sort of catalyst to your revision studies. Okay, so the questions in the paper are linked to the revision material, literally page by page. So if you work through this document comprehensively, you'll find that you should go into the exam feeling pretty confident that there'll be no real surprises as to what's going to come up. However, that's not saying that I guarantee that you're going to come out with full marks. It's just saying that the whole purpose of this document is to help prepare you um, so that you can basically have an idea of what's going to come up in the exam. So let's get straight into it. So biodegradable polymers. So what we've got here is a group of polymers that will break down when they're exposed to certain elements. Now, there's different types. We've got oxo-degradable polymers, photodegradable polymers, and then hydro. Now, the key is in the first part of the word there, oxy, photo, and hydro. So the meaning of these words here is oxy refers to oxygen. Photo means light, or in this case, UV. Hydro refers to water. Water, or actually just moisture generally. Okay, so what happens here is as the polymers are exposed to these elements, they gradually start to break down. You can see here, this image shows an example of a photodegradable polymer up above. So what happens is gradually the polymer chains break down and you get to a point where the whole thing just ends up turning to dust. Now, the good thing is with biodegradables is that they're often based upon, in fact, they're always based upon natural ingredients like cornstarch. I mean, all of these really, they're based on some kind of vegetable extract or vegetable starch. The cornstarch is extracted from corn. You got PLA, which is polylactic acid. And they're all basically the same, but it's worth doing a little bit of research on each one. You can find that in the textbook under the topic number. But the whole point with these is that they degrade without leaving any hazardous chemicals going into the ground. They are clean. Unlike, I mean, all materials will degrade eventually, but biodegradables, they degrade much quicker, and they will basically not pollute the land in which they're degrading into, and that's the most important thing, really. So yeah, so that's kind of an overview of that there. Have a look as well at the sorts of things that they're typically used for, because certain ones like potato pack, they're more used for like sort of even like paper-like food containers. So make sure you got some ideas of what they're used for. Okay, so the next one is the health and safety of different products and the implications for consumers and manufacturers. So we've got one here called the BSI. Now that's synonymous with this thing called the kite mark. So BSI stands for British Standards Institute. Now the British Standards Institute is pretty rigorous. Oops, sorry, I shouldn't try and talk and write at the same time. It's pretty rigorous, and it's very difficult for manufacturers to get the kite mark onto their products because there's a lot of stringent safety tests that the products have to pass. Another one that you see commonly is one that looks a bit like this. Now that stands for the Conformity European, which means that it's basically passed the test to be able to sold in Europe, but the BSI is sort of even harder to pass. A lot of countries and regions have their own safety quality mark. So the whole point of the kite mark is that it's it's basically saying that the product is safe for use in the country where it's been certified. So that's why I've said it meets certain criteria. Products cannot be sold in the UK without this, and it ensures a good level of quality. Great examples to look at with here, particularly things like anything baby related, because parents obviously want to make sure that what they're using is really safe. And also litigation. I mean, if there is an issue with a product, if it's past the BSI standards and it's got the kite mark, then it sort of protects the manufacturer as well. So it offers that level of reassurance. The other one that's worth knowing is this one here called the lion mark. Now, the lion mark is in relation to child's toys in the UK. So, if a toy has a lion mark on it, that basically means that it's safe and it's passed the safety tests. Okay, the next one, stock forms. So you might get questions come up in any exam which talk about, like, explain the benefits of stock forms to the manufacturer, or something like that, or give a few benefits. So stock forms, the first thing is we need to know what are the typical stock forms for each material group. That's always a good thing to do. Yeah, and knowing the actual technical names, so things like rough sawn, plain square edge, plain all round, and then with the metal, it's got sheets, rods and bars, tubes, beams, ingots. Polymers got tube, pellets, sheets, and rods. So thinking about, like, in what way do these benefit the manufacturer? So sort of things to think about are always things like shipping. Shipping set sizes of materials is always cheaper because they know exactly how much a material can fit onto one container. Planning production. If you know how big, say, a sheet of plywood is, you know how many products you can cut out of one sheet. And yeah, like, I mean, there's a ton of different of benefits. I mean, it's actually even things like lower cost compared to if you say to a materials manufacturer that you need a certain size sheet of plywood that has to be to your exact specifications. It's more expensive to do that than it is to do just to use the standards forms that you get from the manufacturer. And because of that, you're less likely to get delays in your shipping as well. And also they're easier to store because often storage facilities are set up for certain size stock material. So those are kind of what the advantages would typically be. Okay, so moving on, we're then getting into finishes of materials. Now, with this, think about materials and how they're finished and why they're finished at all, because there's really the two reasons. You've got functional reasons, and then you've got aesthetic. So aesthetic is referring to, say, with these lovely anodized aluminium parts here, the aesthetic with these, they have this very lustrous color, really, really lovely finish on them. But the functional purpose to this is that it adds a really hard layer to the outside of the aluminium. This makes for a very, very hard layer. And it's also an actual insulating layer as well. It doesn't conduct electricity when it's being anodized. Now, the method I want you to look at is one to do with metals, which is this one here, specifically called powder coating. I want you to look into this in a bit more detail, watch some videos on YouTube and get a better understanding of what powder coating is all about. And why is it better than just, say, spray painting? Better than spraying. I want you to think about this, or go and research it, question mark. There we go. Okay, next one, on to protection of designs. So with these, there's various terms that we need to be familiar with. So copywriting protects the owner, legal protection if they're copied, and applies to written content or ideas. And that's very different to what's called a trademark. Trademarks are often used for they are used for logos. So you often see, like, you'd have like Coca-Cola, and you might see TM in the corner above it or something like that. So that's very different. So it's often used to protect, like things like slogans or images. And it's basically saying that you can't just go and use, say, the Coca-Cola logo on one of your own products and then make commercial benefit from it. You have to pay Coca-Cola for that license. And then the other one is patenting or patent. There's really two, to be honest. Patent. If you've got a patent on a product, it'll say patent number, and then that means that it's actually been registered and approved for patenting. So you have patent number, whatever that is, or it'll say patent pending, like we've got here. PP, patent pending. So what a patent is if you've actually invented something and it's completely original, you have to pass it through a patenting office for the country that you live in. And if the government agrees that there's nothing that already exists that does that thing that you've invented it for, then there's every reason that you'll be granted a patent. And if they deem it original enough, they'll grant a patent for it. Now, patenting takes a long time, like a very, very long time. Yes, to actually get a patent approved can take, over a year, and it's a very lengthy legal process. However, it's worth doing if you really do believe that you've invented something original, because what it then means is you have a protected idea and it's government ratified. So that means that if someone copies your idea or they use your invention for something else without paying you or without crediting you, you can sue them. It also means you can actually lend or license another manufacturer to use this technology. Now, this is groundbreaking. So when Apple developed multi-touch technology, they immediately patented it because they knew that they'll be onto a winner, because what they can do then is they can, when other companies want to use multi-touch technology, use the same thing that Apple invented, they have to then pay Apple to basically borrow that technology. And they pay Apple like a revenue for it, or a percentage of their revenues goes to Apple. So it's very, very lucrative patenting if you actually have a really, really impactful idea. Okay, getting on to environmental impacts of materials. Now, this when you've got a comparison question, it might be typically up to 6 marks with this. So if you're comparing the two products here, you're kind of looking at like which material has a more significant impact. Now we've got here probably a PET cup, and we've got like this will just be a paper cup, but it'll be a paper cup with a very thin plastic lining. Now this is actually called duplex board, so it does actually have a plastic lining on it. So what you need to, the question will actually give you the details of the materials. I've not done that here, but you're basically weighing up the pros and the cons. Compare means give a balanced argument, impartial argument. So you're not saying that one's better than the other, you're just weighing up the pros and cons. So yeah, have a read through the notes that have been made here.